Welcome back. Our next presentation will be by Justin Castilla. He'll be talking about There and Back Again, but by I-5 for the ferry. Justin is a web development bootcamp instructor. No, started his software engineering career as the web development bootcamp instructor, where he developed a passion for exciting others with new concepts and empowering individuals with the tools needed to excel in their own right. Let's welcome Justin. Thank you.
Thank you very much. Hello, everybody. My name is Justin. I am badged as an employee for Elastic. So you might have seen me at the booth, in the booth expo room. I'm a developer advocate. I like searching for things. I like data stores. You might have slightly remembered me 3 years ago when we were presenting in the other room. That was the first time I actually presented as a public speaker. And that was awesome. So thank you very much, PyCascades, for allowing me to initially speak then and speak again now. So I live in the Pacific Northwest, and I live on the Olympic Peninsula. It's beautiful. I have coffee with Sasquatch. I run around with all the Twilight vampires. Everything you expect that happens there is absolutely true. The problem is commuting. From the beautiful Olympic Peninsula to Seattle. I have lived in Seattle. It's too expensive to live there now for me. But I grew up in the Olympics, so I am comfortable and I love taking the ferry. But there are so many different existential crises that you face with a ferry. When is it going to disembark from your location? How long is it going to take me to get there? Which ferry should I take to get to Seattle, at different timetables? If I drive longer, can I take this earlier ferry? Is it worth it? What's my emotional quotient? Do I want to look at like the ocean and the sound? Do I want to look at whales and have a delicious beer on the ferry on my way to work? Or do I want to drive? I don't, but it's always an option. So, Justin, you're saying, why don't you just take Google Maps and just listen to whatever it says? Well, there's nuance to it. First, let's take a look at, getting the mic zone here. Let's take a look at all of my different options to get from where I live in beautiful Port Orchard over to Seattle. I can take the Southworth Ferry, which moves me across to West Seattle. I can go north into Bremerton, or I can go to Bainbridge Island and I can head into Seattle, or I can go all the way up to Kingston, which it's so far north, you might as well annex it. I can take Kingston to Edmonds and then go south on 5 into Seattle. Again, that's a living hell. Or I can drive all the way around through Tacoma, through Puyallup. I don't want to do that at all. So I have options at any given moment whenever I have to go to a meetup or a conference, or if I just want to go see a show. In Google Maps, it does present options, but for whatever reason, Google Maps refuses to acknowledge that ferries are on a schedule. It's not some quantum ferry that is at the destination and the origin at the same time, and you can just drive on and instantaneously driving to your location. That doesn't work. So it will tell you, oh, absolutely, go to Bremerton, get on that ferry. But it's not going to tell you, wait 2 hours. So I wanted to build a solution, and I have at my fingertips Elasticsearch, which is a data store that is really, really good at querying data, either with full text search or semantic search. And I have their expense account where I can just churn an LLM of my choice to my heart's content. It'll heat up my whole room. So I said, well, let's make it easier for me to travel. So I first built out what I wanted to do. I want to have my calendar kind of monitored by Elasticsearch so it will index all of my events that I have. I want to use the WisDot API. WisDot is Washington State Department of Transportation. That's going to give me all the ferry times. It's going to give me any delays, locations of the ferry, like terminals, all the information I'd ever want to know about that. And I also want to know the Google Maps API, because I do want to figure out drive time. So if I want to drive all the way around via the 5 and the 16, or if I want to drive to my different ferry terminals, because sometimes it makes, some temporal sense and impact. So I gathered all of my data that I want to play with, and then I kind of built out a table of all the ferry routes, and I want to group them by region because an LLM is not going to have native knowledge like I do about, anybody here from Seattle or around Washington? Okay, so West Seattle is Seattle. I will fight you all for it, verbally. West Seattle, going to West Seattle is a valid option when you're traveling from Southworth, from the Pacific, from the Olympics. Convincing Claude of that was a bit difficult, but through very helpful tables and a little bit of context, West Seattle is Seattle. So I have here basically west and east. I travel west to east to get to Seattle. The Seattle I defined with West Seattle and the downtown Seattle ferry terminals, so that's that little dotted geolocation. So now that it knows that, I'm just going to have fun and just write out code to figure out the best route for myself. Programmatically, no LLMs, no magic logic. It'll just figure it out. I'll enter my starting location, my event, which will contain my address and the start time, and I'll basically give it all the functions required to look up the ferry schedules, to look up the locations, and to calculate all my drive times. And then it'll present me with a very nice, neat table of all my different options. This is basically a laundry list of all the functions I created. So, spoiler alert, MCP servers, we're just going to call them _ server.py. But I wrote all the functions here. Find nearest terminals to where I am, get the ferry schedule, get today's specific sailings, get drive time from origin to destination, estimate the total travel time. So drive to ferry, take the ferry, get off ferry, drive to destination. And then my favorite part, generate expense estimate. So that's going to be able to estimate my mileage from my Google Drive API, which is going to be multiplied by 70 cents a minute, and then added to the total with any parking or ferry costs that I have. And then below, I have two different servers, one for writing and one for reading. So I want to create events. I'll just copy and paste my Meetup or my Luma links, or I'll just tell it, the LLM directly. I'll just paste in a dictionary if I want, and it will enter it into my Elasticsearch index. And then my read server, that will actually query an LLM that is already housed within Elastic. Now that's really nice because I am, by nature of my employment, an Elasticsearch data store nerd where I know a lot of different commands for searching through Elastic. But for people that don't, they can use the Elastic Agent Builder, which is basically an LLM that has access to a lot of predefined tools, and it will actually generate the queries for you. So I'm using that to search semantically for what events am I going to that cover fake digital currency? It will know to semantically search for Bitcoin. So things like that. That's kind of nice. So once I have all those functions tested out, and I'm pleased with their activity, I will give all of them access to, or give my LLM access to all those functions with lots of documentation, lots of context prompting and things like that to give it a good support system. So here's the stack that ended up working for me. Of course, Python. Python is the native language that the MCP servers were created on. And the fastest frameworks that are out there are on Python, so it was a no-brainer. I used FastMCP. Now that is a framework that the main MCP package uses. There was this interesting friendly schism where MCP framework uses FastMCP up to version, I want to say 2, and then FastMCP it was like a friendly separation, and then they continued on to their own developments. Now they're, I think, version 3. So I continued on with FastMCP. I connected to Elasticsearch, and that's basically to store and retrieve all of my events, and also to store the preferred routes that I have. That way I can see if it works better or not. And then the LLM can actually choose that, saying, hey, you took this ferry last time, and you reported it as a success, so we'll just use that one again. And then my APIs, of course, are the WizDot and the Google Maps. Here's just a quick little data sheet about FastMCP. I'm just such a huge fan of their work, and I think that they're extremely responsive as well, as far as getting everything set up, listening to the community as far as what new features they want, and so, yeah, shout out to them. Okay, so MCP servers have 3 major components. There are others, but these are the 3 resources, or the 3 objects I think that you need to know about when you're building one out. Resources, tools, and prompts. Now, resources are static sources of information that are available to an MCP client. This is a little code snippet of me just wanting to pull up the environment configuration. This, as a client, it's not necessarily always the LLM. It could be your own application that you write out. This just allows you to actually call either this URI that you see or directly the function. So whatever works for you. And you name this URI not based off of any established hard namespace, but this is just for your affordance, so you can actually understand it. This @MCP, that is the secret sauce. That's the decorator that MCP uses to convert all of these functions into MCP resources. That's all you have to do. So as you can see here, it's just a simple demonstration function that returns your configuration. But within the resources, you just want to keep to the convention where it returns a static source of information. You can also create resource templates which have these curly braces up in the URI. And that way you can actually make it more dynamic. So you can pick and choose what you actually want to pull up as information. Now you might think that you could use this for a database call, but because that actually reaches out to another service, that's probably best left for a tool instead of a resource. So an MCP tool is what LLMs use. These are the devices that we afford the LLMs to actually do all the magic things that we love now. So it'll send a request with parameters based on the tool's schema. So we define a very well-made function with plenty of docstring, and the MCP tool will have a description, a name, and it will clearly see all of the arguments. It will fill out all of the argument parameters, and it will execute it. Here's a simple example of me creating an event object within Elasticsearch. So this @MCP tool decorator declares, hey, you now have a tool called create event. Use this when you want to create a new event in Elasticsearch. So this is what the LLM will see. And if you have MCPs that you've connected to on your Claude desktop or what have you, you will see this name more often than not. And then right below it is just a simple function where I'm creating an event. This is a small one that I put just for this slide, but usually it will have a docstring, it will have a list of arguments and why they need those arguments, things like that, because the LLM will be looking at all of this. And then we have prompts. Now, prompts are accessible by LLMs. You have to choose them. You actually have to choose to execute them, but that's a good thing. Prompts are going to be basically a use once prompt or context injection. So maybe I want to give it broader instructions about how to do a larger task rather than just execute 1 or 2 tools. This does take parameters like resources, so that's really good. But more often than not, these are quite simple, just F strings that you can actually expand out with the parameters to give custom instructions to your LLM. The LLM will follow those instructions to your needs, and it will call tools as it goes through that prompt as it sees fit. And here's an example of a prompt, just a simple @MCP decorator, the name, get there with a buffer. So if I want to get to a certain location within X amount of minutes so I can get a coffee, get some air, change a shirt, whatever I want, I want it to actually do it with 20 minutes to spare. So I will call this function, or the LLM can call this function, and I will input a parameter of the buffer minutes. So default is 10, I can make it 20, I can make it 30, and it will populate. So origin, destination, event time, then buffer minutes. It will populate this string, and then the starting location is my house. Find the 2 nearest ferry terminals from my house and calculate drive times to each. So it fills it in, and that is what is given to the LLM. So in the huge field of agentic AI and everything changing every month and all these new technologies coming out, MCP is kind of being collapsed down, and that's fine. That's very, very fine. Agentic AI uses MCPs. If you're creating sub-agents or agents in a large orchestration of many different agentic AIs working together, they're all going to use MCPs as tools to do their tasks. And that's great. MCPs have become a very integral part of this whole ecosystem. So let's check out some of the code. So I'm going to start with the WizDot server, and this is going to be the one that actually looks up the ferry times, establishes like your Google Drives and things like that. So I'm just pulling up, I'm importing fast MCP. Is this big enough? Okay. Your thumb is the most important for me, all the way back there. Thank you. Appreciate that. So here I am defining the server, so it's going to be wiz.ferry. I have just terminals and terminal IDs. This is a government-funded API in the United States, so it's not the best. So just had to give it a little help here with some local data tables. Here's also terminal locations. I added the Latin long. Crossing times. It's just much faster if I just keep it here. And then also I have the different endpoints so it can actually reach out. So these are all helper functions that are going to assist my main tools that I have for the MCP. Let's get to a real one. Takes a while. So there we go. MCP tool, find nearest terminal. So this is going to take an origin, and it's going to find, or in this case, an address string, and it's going to tell me which ferries are the closest. And so the LLM sees the name of the tool, it sees the description, geocode, and address, and return the closest Washington State ferry terminals, sorted by distance. And then this is just going to call the helper function, find nearest terminals, and that's going to kick off that cascade of helper functions to actually give me a list of the nearest terminals. We also have get ferry schedule. So this is going to find the specific schedule for the ferry that I want to go to for this particular date. And it's also going to parse out just the sailings that will get me there in time. That's very important. And then get today's sailings. So that one's going to take maybe where I'm leaving, where I want to go, and then if there's any left, just show them to me. One cool thing that I actually really am kind of stoked about is how I'm not exactly having to query Elasticsearch when I'm looking for my events. What is happening is I'm having my LLM ask the question towards the Elastic agent. The Elastic agent, which is hosted over in Elastic servers, is actually then taking that query, synthesizing it into actual Elastic formal query language, running the query, and then sending it back. So you can actually connect to our full text or semantic data stores and run semantic search or hybrid on my data points, and you don't actually have to set anything up for querying, which is awesome. And so, similar to the WizDot, I created a fast MCP server, events read. And then here we go, search events. And this one basically says use natural language, be very nice, be very polite. You're speaking to basically yourself. And then here we go. Here's the search events. The query, which is a string that they put in that is usually just a copy or a slightly expanded version of what I ask it. And then a conversation ID to be able to maintain that context. And then here we go. Get client is the connection to the actual Elasticsearch agent. And then chat is the command, of course, to chat with that Elastic agent. And then it sends off that query like, what are my next 3 events? Or what events are happening on Capitol Hill? Or what are the events happening in North Seattle? You can actually take those, search through my address, the descriptions of those events, and it will return relevant results. And then for write server, I actually do have to write code to index documents into Elasticsearch. Allowing an LLM write access to a database can be very expensive. And it can create all sorts of shenanigans. But because I trust myself, and because this is a relatively safe app that's not going to launch missiles or anything, I'm creating the access to create an event to my LLM. So here's a description, add a new event to the events index. The description is automatically embedded using Gina embeddings, so it becomes searchable semantically right away. So I'm just telling it it doesn't have to worry about embedding things or converting to vectors. I tell it what it needs to actually input from what I tell it, so I can tell it to look at this Luma event. I can paste in a URL, or I can just tell it exactly with my natural language what it's wanting. It'll look at the args to make sure that everything is correct. It'll know what format to have it in, and then it will execute with es.index, which will create an event in the events index. I also have an optional save travel plan, so if I have a travel schedule that I like, I'll use that, and it will actually look it up next time. It's like, oh, last time you went up to Capitol Hill, you took this ferry and it got you there at 6 p.m. Does that still work for you? I'll say yes, and then Bob's your uncle. We'll both agree that I'll use that route. Kind of like a semantic cache, but not really. I think that's the only real cool fancy one. All right, so let's give this a try. It's always fun having him up on stage. So, what are my next events? So I have in here events read, events write, wiz.ferry. Those are my 3 MCP servers. And then add from wiz.ferry, user preferences, and plan trip. Those are my prompts. So you can actually execute prompts here. I don't have resources in here because I didn't define them, but also LLMs don't use resources. They just assume that you're going to have tools that will give them the relevant information. Okay, so loaded tools, use events, read integration. This is actually a really good way to kind of debug when you're building out your MCP tools. This will show you loading tools. It'll show you all the tools afforded to Claude. It doesn't load these tools at runtime because that will actually chomp into its context and it will cost you tokens in the long run. It sees that I have the search events somewhere in here. There we go. Events read search events. It sees that I have that tool given to it, so it's going to call search events. I can see the request. What are my upcoming events after today, March 22nd, 2026? We had to have a talk that it wasn't 2025. Kind of blew its mind, so now it's definitely sure. And it gave me just this big, gigantic, beautiful dictionary of all of my events upcoming. This is passed from the Elastic agent to this local LLM, and then the LLM has that information with it now to make an informed decision about what to do. So now it's telling me this week, March 26th, SRECon America's Sundown Social, and then 27th, Bremerton Harborside Convention Center, I have the Kitsap Tech Meetup. No rest for me. So, oh, it's giving me the whole thing, yeah. Some of this information is not correct, just so you all know. We're not going to PyCon 2026 in Pittsburgh. It's just, I told it to make these things up, but it got a little truthy. You've got 4 speaking engagements coming up. Want travel planning for any of these? Let's figure out a commute for the SRE event. So this one is coming up. I'm going to have to be at the SRECon in Seattle from 7 a.m., and this event ends at 9 p.m. Wish me luck. All right, so it starts off by calling estimate total travel. So this is going to start with the destination, the origin being the general location of my house, and the destination is going to be in Westlake Avenue in Seattle, and then when I need to be there. Those are the most important pieces of information for it. So it's going to give me all of the location of like how far to drive, how long it would take for me to just drive, how long it would take for me to take the ferries and what ferries I can take. And then it's also going to look up ferry expenses. So now it's going to find the tool and it's going to analyze the cost of traveling with all of these. And let's see what it says. Let me make this a little bit smaller. These are my different options. I can drive to Bremerton. I can take the Bremerton ferry. And that's just a very short little drive from the ferry terminal to Westlake Center. Total cost is $27.76. Recommended because it's 16-minute drive to the terminal, 60-minute crossing, 50, but whatever. And then 10 minutes to venue. The Southworth, the Fauntleroy ferry, it actually departs at 6:55. It takes 67 minutes total because it's closer to my location. It only takes $28, and it's the fastest overall, shorter crossing, but a longer drive because I'm going to West Seattle, which is Seattle, all the way to downtown. And then there's driving through Tacoma, through Gig Harbor, and I would be driving through reverse commute traffic, but it's still traffic. And let's see here, it costs $43.21 to Elastic, 61.7 miles one way. No ferry dependency, good backup if you miss a sailing. That's true. So I have at these, within this table, 3 different options that I can choose from. Now I can pick, based off of the vibe, like there's no way on earth I'm driving through 16 and 5 today. Or, I really, really just have to have some time to crunch so I can actually, update my slides, catch up on emails, things like that. I want to stay on the ferry. Gives me a nice little wordy breakdown of which one I should choose. So let me tell it, let's save the Southworth route. And then it will launch a right. So it's going to find the event for the SRECon evening social, and it's going to attach to that social event an embedded object of the route that I chose. So let's take a look at it. So it's looking for SRECon America's Sundown Social. Says it has a conversation ID. So my agent, it looks like in Elastic, decided not to give the actual ID of the data store. It was just giving a very nice natural language response. Oh well, that's my misgiving. I didn't actually have it. I need to actually work on my context for my agent to return the actual document ID, but that's not too big of a problem. Let me show you really quick what I'm actually talking about with my agent. This is my agent within Elastic. And I'm using an events agent, which is an agent that I define. I give it specific context to what I want it to do. I can also give it predefined queries that it can use against the queries that I pass it. And then you can see here, all the questions that I was working with on Claude has been funneled over to my Elasticsearch agent. So here we go. Here I was asking it, or Claude was asking for me, SRECon America's Sundown, blah, 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 blah. Here are the full details. And then you'll notice it did not give an ID. So I need to work on the context to actually have it return the ID. That's on me. Let's see if Claude was able to get anything. Yeah, he wasn't able to write that travel plan, but that's okay. That's all me. So yeah, that is my commute helper. It is actually quite useful. I can ask it, hey, I'm going to PyCascades up in Vancouver. What are my options? And it will tell me, like, you can take the ferry. It'll not save you time in the end, and you can drive. But yeah, I think it's really cool. It was a really great way for me to actually learn about building out MCP servers. And now that I know this, I can actually build out agentic frameworks like deep agents or anything with LangChain with confidence, because I can actually build out these very powerful MCP servers. Cool. And that is it. Thank you very, very much.